right, topic 1, lesson 2, wave interactions, found on pages 14 to 22 in your textbook. As always, starting out with the connected. So look at the goldfish shown swimming in the glass tank. Place an X on any fish that you think is a reflection. So light waves reflecting off the walls of a tank can create multiple images of the same fish. So we'll start off by placing the X, and this X is here where we believe this is the reflection. How many real fish do you think there are? I think there are 5 fish would be an example. 5 fish does not have to be your answer. 5 fish is an acceptable answer. Your answer could vary depending on what you think. So why is it difficult to count the number of fish in the tank? And the reflections of the fish on the different panes of glass make it appear as though there are more fish in the picture than there actually are. The fish also look distorted due to the way the light is bent as it passes through the glass. All right, so reflection. In general, when waves encounter different media, they are either reflected, transmitted, or absorbed. Waves are completely blocked by an obstruction, but their energy is not absorbed or converted to another form of energy, so the waves bounce off and head in a different direction or reflect from those obstructions. So that is what causes a reflection. What is a reflection? So the law of reflection states that the angle of incidence equals the angle of reflection. This means that the angle at which the wave strikes the material will match the angle at which the reflected wave bounces off that material. Light reflecting from a mirror is the most familiar example of reflection. The echo of a voice from the walls of a canyon is another. All right, so the planet. Have you ever seen a movie scene in which a character appears to be looking at a mirror, yet the camera is not visible in the mirror? Think about how the director set up the scene. Draw a setup that shows the position of the actor, the camera, and the mirror, and demonstrate why the camera's image is not visible to the camera. And you need to do that independently. All right, moving on, refraction. So refraction is the bending of waves due to a change in speed when light waves are transmitted from one medium to another. When a wave enters a new medium at an angle other than perpendicular, it changes direction. For instance, when light is directed at water at an angle, the light slows down and bends downward. The wave bends toward the normal, the imaginary line that runs perpendicular from the boundary between the two media. So here we have an image, figure 3. Light rays bend as they enter water because one side of the wave front slows down in water while the other side continues at the same speed in air. Diffraction. So did you ever wonder how you can hear someone speak even if they are around the corner of a building or doorway? Diffraction is the bending of waves around objects or through an opening. You can observe diffraction with water waves as well as sound waves. Water waves can diffract around a rock or an island in the ocean. And these are all kind of images of what that looks like visually, things diffracting or spreading out. Absorption. Absorption is the energy of a wave that is transferred to the material it encounters. Like a paper towel soaking up water, waves can be absorbed by certain materials. An example, when ocean waves reach a shoreline, most of their energy is absorbed by the shore. Light is mostly absorbed by dark materials, such as the surface of a parking lot, and mostly reflected in lighter materials, such as snow. All right, the question is, identify each picture as being an example of reflection, refraction, or absorption. So this first one is diffraction, because you can see the waves, it hits something and then it spreads out from where it is in a different pattern. Then we have refraction, absorption, And finally, reflection. Wave interference and construction. Constructive interference is two waves of similar sizes colliding and forming a wave with an amplitude greater than either of the original waves. Waves helping each other or adding their energies together. The amplitude of the combined crests or troughs increases. Then destructive. So destructive interference is two waves combining to form a wave with a smaller amplitude than either original wave had. The crest of one wave overlaps the trough of another wave. If the crest has a larger amplitude than the trough of the other wave, the crest wins and part of it remains. If the original trough has a larger amplitude than the crest of the other wave, the result is a trough. If a crest and a trough have equal amplitudes, they cancel each other out. Reading check. Which type of wave interference could cause sound to become louder? Explain your answer. Constructive interference, because the waves interfere such that the crests overlap and the amplitudes add together. All right, so reviewing that stuff that we just did with figure 4, types of interference. So write captions to describe 3 parts of destructive interference. Complete the key to explain what the different arrows mean in the images. So first we're going to start with the key. The right arrow shows the direction of wave 1. The red arrow, not the right arrow, it is going to the right, but it is red. The blue arrow going to the left shows the direction of wave 2. The up arrow is the amplitude of wave 1. The down arrow is the amplitude of wave 2. And of course, they correspond to both. So the blue arrow is wave 2, the red arrow is wave 1. Red everything is wave 1, blue everything is wave 2. Then destructive interference. So for the first one, 2 waves with equal amplitudes approach each other. The crest of one wave overlays the trough of the other wave, and they cancel each other out. The waves continue as if they had not met. So that's kind of what's happening with destructive interference. Standing waves. So a standing wave is a wave that appears to stand in one place. Standing waves are produced by 2 waves interfering with each other as they travel in opposite directions and collide. Nodes are points with 0 amplitude in a standing wave, always evenly spaced along the wave. Antinodes are points of maximum amplitude on a standing wave, and they always occur halfway between 2 nodes. The frequency and wavelength of the interfering waves determine how many nodes and antinodes the standing wave will have. When seen in real life, the antinodes appear to pulse in and out from the rope's rest position while the nodes appear motionless. So figure 6, standing waves. As the hand shown at left increases the frequency, the number of wavelengths present in the standing wave will increase in a standing wave. It looks like there is a mirror image of both the crest and trough. Label the rest of the nodes and antinodes. So antinodes are at top, nodes are the intersecting points on the line of rest. So we continue with that and it would look like this: antinode, node, antinode, and then at the bottom we'd have antinode, node, antinode, node, antinode, node, antinode. Resonance. So resonance is an increase in the amplitude of a vibration that occurs when external vibrations match an object's natural frequency. Reading check. In general, why is it risky to build something whose natural frequency can be matched by external vibrations? That's because the amplitude of the waves in the object can be increased to the point of damage to the object or sound that is too loud or harsh. All right, so that finished the lesson, and now it's time for a lesson check. So 1, explain what happens to light when it's refracted at the surface of water. And the light is bent as it changes speed when it moves through a different medium. 2, the diagram below shows 2 waves interfering to form a dark blue result. Which of the diagrams depicts constructive interference? Explain your choice. Choice A, because it shows waves approaching each other and their amplitudes combining to form a wave of larger amplitude in the middle as the waves pass through each other. 3, what does it mean for waves to be absorbed by a certain medium? Make sure to include energy in your explanation. So the energy of the wave is transferred to that medium or material. 4, why does the transition of light waves from water to air make it seem as if fish and other things in a pond are shallower than they actually are? This is due to refraction. Light that reflects off the fish bends as it exits the water and travels to a person's eyes, due to the different speeds of light in the two media. And that concludes this lesson. Thank you.